So actually, it was quite striking when people started looking at the possibility that the cells that are not the mutant cells that give rise to the hematological diseases, but rather the microenvironmental cells, whether they might play a role, they started generating alterations in non-hematopoietic cells. These were different types of alterations expressing molecules that were mutated in the case of germline mutations during hematological malignancies, but in other cases were simply alterations in the non-hematopoietic cells. And it was quite striking that in most of these experiments, the mouse models developed a type of disease that resembles myeloproliferative neoplasms. So that suggests that there is an important role for the non-hematopoietic cells in the development of these diseases. This was observed many years ago, and then people started, looking at what cells might be more important compared to other cells, and then found some evidence that really niche could be an oncogenic inducer for the development of these malignancies. But most of the evidence of the role for the microenvironment actually is as a consequence of the mutation in the hematopoietic cells, whereby the microenvironment gets altered and it stops functioning properly to support hematopoiesis, and it starts instead promoting the development of the malignancy. So that alteration of the microenvironment actually can develop over many, many years. And some of these mutations are now detected even before birth, but the patient only manifests with the disease typically associated with the elderly. So clearly there are many things happening in the microenvironment over many years that might just give rise to the disease development. And therefore, now that these diseases are actually detected quite early, there is an opportunity for early intervention and prevention of this damage of the microenvironment impede either disease progression or treatment of the disease once it has developed. So the most interesting findings suggest that the niche has some capacity to control the expansion of the mutant clone that is driving these diseases. And actually we found that in disorders such as myeloproliferative neoplasms, where there is a variety of manifestations and with different level of disease expansion or mutant clone expansion and transformation into the more dangerous situation for the patient, this heterogeneity also is related to the different interaction with particular microenvironments. And we have identified certain molecules that are involved in these interactions, and we think we could target those to restore the normal interactions of hematopoietic stem cells with their niche and prevent, the abnormal, for instance, detachment from a niche that is good at controlling the expansion of the stem cell and is relocating to a permissive environment where the mutant clone can expand more freely. So I think that's an exciting sort of opportunity again for intervention, probably as in complement to the actual targeting of the mutant clone. It's definitely there is a revival in the research around the microenvironment. This is also encompassing the immune microenvironment that has been studied mostly in the context of solid tumors, but now there is a huge interest also in the immune microenvironment for hematopoietic cells, because clearly these immune evasion mechanisms are also modified through interaction with the microenvironment. And when you come up with an immunotherapy, you need to make sure that you don't find an immunosuppressive microenvironment that won't make these reprogrammed cells work as efficiently as you'd expect. And also there are interesting sort of regulation through the macrophages that are involved in the clearance of some of the mutant cells. Not only the adaptive immune system, but also the innate immune system is very important in this context. And the microenvironment, depending on how immunosuppressive or stimulatory it might be, it might participate in the response to this immunotherapy. So I think this is an important area.